All right, so this new unit is going to be all about functions, okay? Now you're gonna hear this word a lot. You've probably heard this word a ton, right? Now that you've had secondary math 1, 2, and now 3, okay? Well, we are dealing with operations and function notation today. So let's go ahead and just define what it means with this function notation, okay? Because mathematicians, they're particular about it, how it's written sometimes. So function notation literally means it's written like f of x equals g of x equals, okay? Instead of y equals. A lot of the times with the equations we've worked with, you see a lot of like y equals. Okay, I'm seeing people on their phones, put them away. You're being rude. Yes, yes. Okay, so that's simply function notation. Okay, so what you're gonna see a lot of today is then we're dealing with our 4 operations, our 4 main operations. Okay, so the 4 operations being addition, subtraction, multiplication, and division. So basically what we are going to do today is add, subtract, multiply, and divide these functions. Okay? Sounds very extreme. It's really not. Okay? So let's go ahead and define what it's going to look like. So over here on the side of my paper, we know that function notation, if it's written like this, technically it's a function. It's written in function notation. Okay, so you're going to see if we are adding the 2 functions, it'll look like that. All that means is add function f and function g. Okay, if it's subtracting the 2 functions, you'll see it written like that. Okay, if we are multiplying the 2 functions, it'll use that little multiplication dot. Means multiply those 2 functions. The x just means x is that variable, function f of x. Okay, and if we're dividing the 2 functions, it's going to be written like a little fraction, right? Because we know that technically means divide. Okay, so that's all we're going to do today is just practice using our operations, addition, subtraction, multiplication, and division with these functions that we're given. Okay, so let's go ahead and look at number 1 now. Okay, so I am given 2 functions. I'm given g of a and I'm given h of a. It really does not matter what variables they're using. Okay, this is our first function, this is our second function. Okay, what is it telling us to do with these 2 functions? It's saying find something of a. What's it telling us to do here? Add, subtract, multiply, or divide them? Divide them, okay? Whenever we see that little fraction, we know we need to divide these 2 functions. Okay, now it matters which one is on top and which one is on bottom. Which one is on top?
G.
G of a. Good, so we're gonna take g of a, which is 3a, and on bottom would be h of a. So we have 3a divided by a squared plus 3a. Okay, now here's the thing. That is technically the answer. We're taking that function and we're dividing that function. But in mathematics, especially in higher mathematics, it wants it to be simplified. Okay, do you think this guy's simplified? Nope, it's just like our ratios on our starter. We have to reduce it. So here's how we have to do this. Just look at the numerator. Can I factor 3a? You guys remember what factor means? Like break it down anymore? No, right? Can I factor or divide something out of the denominator?
Yes. Yes.
What can I take from both a squared and 3a? What can I factor out?
A.
An a, right? They both have an a. So can't factor the numerator. That just stays 3a. But I can take 1a from each of those terms, which means I can factor out a single a, leaving me with 1a left from a squared and just my 3 left from the 3a. Okay, so that's not too bad. Now it just becomes a fraction. What do you guys see that's the same on top and bottom that can cancel out?
A.
Ooh, I love that we brought this up. The a I agree with. right? These a's can cancel out. Why can I not cancel the a inside the parentheses or the 3 inside the parentheses? Is it its own little piece, or is that whole thing a piece?
It's its own little piece.
Is the a its own little piece and the 3 its own little piece, or is it all one piece?
All one.
It's all one piece, right? 3 is not the same as a plus 3. So those are the only things that can cancel. So my final answer here, simplified, is 3 over a plus 3. There we go. We're simplified. Okay, we divided and we simplified. Okay, it's okay, we don't have a ton of room for number 2 because what is it telling us to do with these two functions? Add, subtract, multiply, or divide them? We're asked to add them, okay? And that's not too hard. Okay, so what we're gonna do is we're gonna take g of t and add it to h of t. So we have g of t is 4t minus 4. We are adding it to h of t, t squared minus 1. Okay, but what I'm gonna do here, since we're adding that whole piece, do you guys remember the rule? I know we've talked about it multiple times. When there's an addition sign, do my signs after it stay the same or do they change? They stay the same, okay? The parentheses, we technically don't need them with this one, but when we get to subtraction, we will. But all this becomes is combining like terms, right? 4t minus 4 plus t squared minus 1. Where are my like terms that I can
4t
combine?
and t squared.
Can I combine those two?
Or minus 4 minus 1.
Good. Okay, my only like terms here that I can combine are the negative 4 and the negative 1, right? 4t is not a like term with t squared. Same variable, but they're not the same power. Okay, well, what is negative 4 minus 1 more? Negative 4 minus 1 more?
Negative 5.
Negative 5. Okay, so that just turns into negative 5. Now, usually we like to write the biggest guy or the biggest power first, so t squared is going to come first. Okay, then it's a positive 4t, so he'll go in the middle. And my negative 5 on the end. And there we go. There's my new function. When I added those functions together, it just becomes a new function. Cool, cool. Okay, what is it asking us to do for number 3? Oh, we're asked to divide it again, right? We see the little fraction. It's saying take g, divide it by f. Okay, so we're doing the same thing as number 1. We're going to take g of n squared plus 1, and divide it by f of n minus 4. Okay, now, just like on number 1, when it's a fraction, we always want to make sure that we can simplify. Is there stuff that we can cancel out? Think reduce. Let's look at our numerator. Can I factor or divide anything out of n squared and 1? Do they have anything in common I can take out besides 1?
No.
No. So that guy is factored. Can't factor him. What about n minus 4? Can I take anything out of
1 minus 4? Maybe 1?
anything besides 1?
No.
Nope. So is this guy simplified?
Yeah.
Yeah, he's simplified. Boop. There's our answer. And sometimes it really is that easy. You just have to make sure if you can simplify it, if you can combine like terms, if you can cancel things out, we got to do that. Okay, now comes the fun one. Ooh, number 4. What is it asking us to do with these guys? Here are two functions. What's it asking us to do?
Times.
Multiply them. Nice. So we are asked to multiply. We see that little multiplication symbol in the middle. Okay, so this time I am going to use parentheses. Whenever we're multiplying, we like to use parentheses. So I'm going to take my h of t, negative 2t minus 3, multiply it to my negative 2t squared minus 5t.
Oh, this is FOIL.
Yes. Yeah, FOIL is just multiplication. Okay, just remember whenever they're written right next to each other, that means we're multiplying them, so that's why we use the parentheses. Okay, and yes, if you heard Eli, that method that we really love, or you can use the box method if you want, but I really like FOIL too. Think of it as like little swooshies, which means we're gonna take our first term, multiply it to both of those terms. Okay, so let's see what we get. What is negative 2t times negative 2t squared? What am I gonna get there? Think negative 2 times negative 2 first. Negative? Negative times a negative?
Oh, it's a negative. I
4.
didn't write that
So
down.
positive 4. Okay, so we're going to get positive 4. And then I have 1t multiplying to 2t's, so positive 4t cubed. Okay, that's just my first term. Donovan, I should not see your phone out right now. No, I don't care. All right, okay, then we're going to take negative 2t times negative 5t. So again, think negative 2 times negative 5.
10.
Positive 10, great job. And then 1t times another t is 2t, so 10t squared. Great, first two terms taken out of the way. Now we just need to take that negative 3, multiply that guy to both terms. So we're doing the same thing we're doing with FOIL, we're just kind of condensing it. I like to call them the swooshies. Okay, what is negative 3 times negative 2t squared? Negative 3 times a negative 2.
Six.
Positive 6, beautiful. And then there's just those two t's again, so positive 6t squared. And my last guy, negative 3 times negative 5t. Negative 3 times a negative 5.
15.
Positive 15. And there's just one little t being multiplied, so positive 15t. All right, you guys, are we simplified? That's just another function, but are we simplified?
No.
Why not?
It's too long.
It is too long. Let's make it shorter. What terms can I combine?
10t squared and 6t squared.
Got it. Boom. These are the only like terms that I can combine.
Would it be 16t?
You got it. Okay, so 4t cubed is still going to go in front because they have the biggest power. 10t squared plus 6t squared does turn into, whoops, that's an ugly 6, positive 16t squared. And my plus 15t on the end. And now we are simplified. Beautiful. Okay, let's go ahead and skip number 5. We've done enough division for one day. Let's just go down to number 6. Okay, this is a good refresher. I'm given two functions, g of n and f of n. What am I asked to do with these two functions?
Minus. Subtract.
Subtract them. Beautiful. Okay, this order does matter with subtraction. So we're taking g of n first, n squared minus 5n. And we're subtracting f of n. Notice I am going to use some parentheses here. I'm subtracting that whole function. 3n plus 4.
The signs change.
Yes, okay, this subtraction sign right there, remember he jumps in and he changes the signs after him. So this is going to turn into, let me write it in a different color. Boom, boom, they change those signs. So now I have n squared minus 5n. Positive 3n turns into subtract 3n. Positive 4 changes to negative 4. Great job remembering that that subtraction sign changes the signs after it. Does not affect the signs in front, just the signs after. Is it simplified? It's a new function, but is it simplified?
No.
What can I combine, Braden?
Negative.
Negative 5 and negative 3.
You got it.
Negative 2.
Oh, are you sure? Negative 5 minus 3 more? I'm getting more negative here.
That's 8.
Oh.
Negative
I don't know
8n. Okay, so my final answer is n squared, stays in front,
Very.
minus 8n
Minus 4.
minus 4.
That was simple.
Not bad. Show me a fist of 5. Adding, subtracting, multiplying, dividing functions. How you feeling?
It's math.
Not bad. Not bad. I like it. I like the 3's. Alrighty, okay. We're taking it up a notch. Okay, but I actually think this way is a little bit easier than what we were just doing. So maybe by going up a notch, we're going down a notch. I don't know. Okay, but what's our directions? What are they asking us to do?
Evaluate each function.
Evaluate. Okay, let's identify what this word is actually telling us. We are going to get a number for an answer. Answer is not a function anymore. It's not a new function or a new equation. It's a number. Like 10 or 5. I don't know, whatever number we get. Okay, if you want to use a calculator, I highly recommend it. They'll help us here. Okay, but what we are given is just one function this time. Here's my f of n function, 3 to the power of 2n minus 2 plus 3. What it's asking us to do here is take this 2 and replace the n with it. It used to be f of n. Now it's f of 2. Which means you're just going to replace the n with a 2. That's all you're doing. Okay, so we're going to take that 2 and plug it into where we see the n. So now this function becomes f of 2 equals 3 to the power of 2, used to be 2 times n, now it's 2 times 2, minus 2, and then plus 3.
Why do be so weird?
They're kind of weird. Okay, but what we need to do first, we got to follow PEMDAS, right? Please excuse my dear Aunt Sally. We got to figure out this exponent first, right? Let's take care of that messy thing right there. Okay? And then within PEMDAS, we got to multiply before we can subtract. What is 2 times 2? 4. What's 4 minus 2 going to turn into? 2. Okay, so this literally just becomes 3 to the power of 2 because it was 4 minus 2 plus 3. Notice we're not dealing with any type of function notation anymore. There's no more variables. It's literally just finding the answer. Okay, what is 3 squared, you guys, or 3 times 3?
6, 9.
9. And then our last step, what is 9 plus 3? Will give us our final answer.
12.
12. Okay, so that's what it means to evaluate it. It literally just means take this number, plug it in to where the variable is, and solve for it. Punch it into your calculator. Okay? So let's try it again. Number 8. We are given our function p of a. What are we replacing a with?
-2.
Good job. Okay, used to be a. Now it's a -2, which means we're taking that -2 and just plugging it into our little a spot. Okay, so let's go ahead and do that. P of -2 equals 4 to the power of 2 times -2, used to be 2 times a, plus 2, and then we'll subtract 1 at the very end. No more variables, we're literally just finding the number, the answer. Okay, let's take care of our exponent first. It's kind of a mess up here. What is 2 times -2? -4. What is -4 plus 2?
-2.
-2. Ooh, wait a second, you guys. 4 to the power of -2? What in the world do negative exponents do? They take you back way to the beginning of this year when we first talked about exponent rules. What does a negative exponent do?
Oh,
Who remembers? It grabs its base and does what?
flips it.
It flips it. Okay, so this -2, think this over 1. It's actually going to grab that 4, move it to the bottom. So what this becomes is 1 over 4 squared. Now it's a +2. And then we'll subtract 1 at the very end. Okay, this is going to be an ugly answer. That is totally fine. Okay, first tell me, what is 4 times 4? What does that denominator turn into?
16.
16. So we have 1 over 16. And in order to subtract from a fraction, I need it to be the same type of fraction. Well, that's okay. 1 is just 16 over 16, right? That's the same thing as 1. I just made it so I can subtract the 2 now. Now that I made the denominators the same, tell me, you guys, what is 1 minus 16? What's my final answer going to be? It's negative 15. So this final answer is a gross fraction, but that's okay. Negative 15 sixteenths. Whoa. You guys know exponent rules. You guys know how to add and subtract fractions. You're fine. Don't let that freak you out.
You have to learn this in measurement.
Okay. Let's do 2 more examples. Number 9. Ooh, what do these bars mean, first of all?
Oh, wait, complete value. No,
It's not complete
Value.
absolute value. Nice. It means whatever you find in here, it's going to turn it out to be a positive, right? Okay, so not too bad. We have h of n. What am I replacing my n with? Negative 9. Oh yeah. We're going to take that negative 9, plug it into my n spot. So this time I have 3 times the absolute value. I'm going to write h of negative 9 equals 3 times the absolute value of negative 9 plus 1. Okay, we need to figure out what's inside our absolute value first, right? Those act like parentheses. Please excuse my dear Aunt Sally. So, what is negative 9 plus 1 on the inside of my absolute value?
Negative 10.
Ooh, super close.
Oh, negative 8.
Negative 8. Okay, so we have 3 times the absolute value of negative 8, but it's an absolute value. Negative 8 turns into what?
Positive.
Positive 8. So our final answer is just going to be 3 times positive 8, which is going to be what?
It's going
3 times 8?
Mm-hmm.
It's going to be
24.
36.
Ooh, super close, 24.
24.
And boom, evaluated. We plugged it in, we found the answer.
Oh, that was 4. I was counting by 4s, not 3s.
Alrighty, let's do one more, you guys. We have our function, h of n. What am I plugging in for my n?
0.
0. Ooh, we love 0. 0 is probably like one of my favorite numbers. Okay, so I'm just going to plug that 0 into that little n spot, even though it's up in the exponents, totally fine. So I have h of 0 equals 4 to the power of 3 times 0 plus 2. That's my entire exponent. And then at the very end, I'm going to add 1. Here's why I love 0 so much. What's 3 times 0? 0. What's 0 plus 2? 2. So this literally just becomes 4 squared. And then I'll add my 1. Well, tell me, what is 4 times 4? 16.
And plus 1 is 17.
Booyah.